SPRE stands for Superior Province Rifting Earthscope Experiment. We're studying the rifting of the Superior Province. That red region that you see north and around Lake Superior on the map behind me. It's the biggest province in our study area, but there's other terrains to the south that we're also studying and that this rift also tried to split apart.
The Midwest today is not very tectonically active. There are no plates moving around, moving past each other, causing earthquakes. But 1 billion years ago, the situation was very different. 1 billion years ago, there was almost an ocean that opened up between Minnesota and Wisconsin. And what remains of that today, we call the Mid-Continent Rift. So the rift is an area where the continent was starting to split itself apart.
When a continent tries to split apart and form an ocean in between the two pieces, oceanic rocks will come up to the surface, will cool down to form a new ocean floor. Ocean floor is made up of basalt, the same kind of volcanic rock that you find on Hawaii, for example. And that basalt is coming from very deep down in the earth. It's a little bit richer in iron than normal rocks you find on a continent. So it's dense. It's denser than the normal rocks. Because of the basaltic rocks, the volcanic rocks, or ocean floor rocks in the mid-continent rift system, the gravity there is higher than you would expect. We call that an anomaly. In this case, it's a gravitational anomaly or a gravity anomaly. It's the biggest clue to the fact that this mid-continent rift system exists and that it tried to split the continent apart 1 billion years ago. And the fact that it didn't is also recorded in the anomaly itself, because whatever there was 1 billion years ago got pushed back together again. And that pushed these basaltic rocks up closer to the surface, that whole pushing together process. These dense basaltic rocks that you normally find kilometers deep on the ocean floor, they're now pushed up and are close to the surface, although covered still by sediments, causing a large gravitational attraction that you would not expect, and we call that an anomaly.
There was volcanism for a period of several million years, but then it stopped suddenly. Right? We don't see an ocean between Wisconsin and Minnesota today. We don't see evidence that there ever was one. So we had an enormous amount of volcanism happening, and then it suddenly shut off. And that's part of what SPRE is trying to investigate, is why did this rift start forming here? Why did it turn off? And is there anything left deep, deep down in the Earth's mantle that can tell us about the rift and how it evolved?
I'm very excited about the part of EarthScope that is to study the evolution of continents, because the way to do that is to put a lot of seismometers all over the continent that can then help image the three-dimensional structure in great detail of the crust and the mantle beneath the North American continent.
There are 83 total seismometers deployed as part of the SPRE project. You can see them here as blue dots on this map. So we have 16 stations to the north above Lake Superior in Ontario, Canada. And then we have the remainder of the stations down here in these 3 lines, sort of one running to the north and south, and 2 lines crossing that array in Minnesota and Wisconsin. The reason that those stations have sort of that funny geometry is because of the shape of the mid-continent rift, right? So we want to study the structure below the rift. So we put our stations above and across the rift so that we can make cross-sections of the rift. The mid-continent rift is this red shape here. This is a map of the strength of gravity in the area. And if you're above the rift, the pull of gravity is ever so slightly higher because the rocks in the rift are very dense.
We have a lot of earthquakes recorded, and we have several graduate students and other researchers that are in the process of digesting all the seismic data from these stations. Most of the seismic data are records of earthquakes from faraway corners of the planet. The farther away, the better, in some sense, because then the seismic waves travel deeper through the Earth's interior before they are recorded at our seismic stations of our SPRE network.
And the reason that I study these waves is because they travel at different speeds depending on the kind of material that they go through. So the waves will travel really slowly through something like a loosely packed sedimentary rock. If they're traveling through something really hard and strong like granite, they'll travel much faster. So by studying how fast those waves travel, I can study what's inside the Earth.
And by comparing earthquakes from all over and comparing different seismic waves that took different paths, then we can slowly unravel, by combining data from all of these earthquakes together, what the three-dimensional structure is underneath the study area, which is the study of the mid-continent rift system. And the structure in this area of the Superior Province and this mid-continent rift system is going to help us understand these ancient processes, but might also help us understand current rift systems and the future of plate tectonics.